Hey everyone, today I'm working on an iPhone 7 Plus that was sent here for not charging. I'm sort of an idiot and I left this thing, I was out of TriStar ICs and I left this thing on the back burner until the ICs arrived. I get it on the bench today expecting it to be just a simple TriStar IC repair, and it's a little bit different, so I think this one might be a good one to do a video on. I've already got the phone opened up here, but I don't have it taken apart yet, so I'm going to quickly catch you up to speed as to where I'm at, and then we're going to fix this phone. So the first thing I did here, let me hook the battery back up. The first thing I did before I opened the phone is I actually hooked it to a lightning cable here, which is also hooked to a current meter. You're not going to be able to see that, so let me get a little bit closer. As you can see, we're at 5.2 volts and 0 amps, so I can see why the shop that sent it here would say that it is not charging. It's obviously not charging. So I'm going to show you what the next step I did here is. Before I get started, I'm going to put my gloves on because I don't like to work without gloves. A lot of people still ask me why I wear gloves, and it's for the most part to keep my grimy fingerprints out of the phone. Honestly, I don't think they cause any trouble whatsoever. It's just a little bit of an eyesore. This phone here, I'm going to put it up to that camera so you can see it a little better. This phone here, it's... Focus, please. Are you going to focus? The one time I turn on autofocus and the damn... Oh, wait, I didn't turn on autofocus. Come on. You know you want to autofocus. Why won't you auto... Are you... Oh, because that's zoom. Can't auto-zoom. Alright. There we go. So, this phone is pretty well pristine. It doesn't have any fingerprints in it. It does have a little bit of a mark here where the front flex was laying. I don't know if you'll be able to see that or not. It's not important, but nevertheless, this thing, it's not all grimy, and I'm going to plan on sending it back out the door as clean as I can. I mean, you can't keep from putting any markings on them, but I can try, and there's nobody out there that can tell me I can't try. You can criticize me for it, but I'm still going to try. Okay, so I'm going to show you now what the next thing I did was. I opened the phone up, and I removed our bottom plate and then disconnected the battery. Okay, now that we have the battery disconnected, I'm going to hook it up to the DC power supply. Just like that. Now, as you can see, we are set at 4.1 volts, and I have my amperage set as high as I can get on one output on the supply. It's at 3.2 amps, and we're not drawing any power with the supply hooked up, but the very moment that we press the power button, we're drawing 2.3 amps. And that's quite a bit of load on the circuitry that powers this phone, so we're not going to leave that on for long. So what this tells me is that this phone does have a short because it's just instantly, boom, drawing way too much power. And it's not a short on VDD boost or VDD main. It's not a short on any line that's powered the moment that you hook up the power. It's a short on some line that's powered later on after it's switched on. So I'm going to take this phone apart and see if we can find the short. Okay, so here is the phone. I would like to apologize to job number 5112 because this phone has been here too long due to... Where's my screw pad? Due to me being out of ICs. I've got a handful of not charging phones that were delayed by this, so I apologize to all of you, but 5112 here, this is the one we're working on today. So okay, so let's go ahead and take the rest of the screws out of this phone and get the screen assembly off of it, and then we're going to proceed to remove the logic board. I am still not completely settled in with the changes and differences here since we've picked up and made the big move, but I'll get there. It has not been an easy transition, that I can tell you for absolute certain. And the red tide down here has really been a drag. I know there's probably quite a few of you watching the channel that have been affected by this. It seems to be primarily the Gulf Coast right along where we live. We've been driving down to like Marco Island, and if you get a little ways north of Tampa Bay, or I'd say around, you know, Naples and on south, I don't think there's much of an issue at all. Marco Island was in pretty decent shape. although I do believe red tide is present there. Okay, let's go ahead and take this. You know, if I try to peck around and poke around at this thing without removing the board, I just, you already know that I'm going to have to remove the board, so let's just skip all that and remove the board, shall we? I'm going to leave the teardown portion of this entirely unedited, so this may, in fact, I might leave this entire video unedited. I think that's probably the best way to convey exactly what it is that I've went through to fix this one. I'm just glad it's not boot looping or doing some other vague thing that you wind up spending half the day trying to chase down a demon and at the end of the day still not find it and leave with your tail tucked. That's getting to be a real drag on the iPhone 7 and 7 Plus, and I know that I'm not alone. Alright, let's take all these standoffs out. That one's not going to come loose because it is being blocked by something. This post here. I get carried away off in my own little world and sort of forget to be sure I'm keeping this stuff in front of the camera. I really need to get this done. We've been receiving, I don't know, 3 to 10 phones per day now for a long time, and with some of the tricky problems that have came in, that makes it really, really difficult to keep up. And not everybody is understanding, but most people are. I'm thankful to have awesome customers. Most of my customers are very understanding, but some of them, really, they owe me a 1-star review for having equipment too long. It's just, you reach a point where you don't know how to fix it. You don't want to give up. It's hard to throw in the towel whenever you still have stones that are unturned. And that's sort of where I'm at with a handful of these. So if you're somebody that's had a phone here in the shop for way too long, I am terribly sorry. If at any point you want me to give up on it and just throw in the towel, let me know and we will promptly send an invoice for return shipping only and get it sent back to you. Okay, so here we've got the board out of it. Now, one thing I did skip, I forgot to mention the housing. Am I still autofocus on that camera? Whatever. The housing along the SIM tray side, it's not severely bent, okay, but it does have a light bow to it. It's sort of across the NAND area. So on this one, the first thing I'm going to check, because it's really, really common on previous models when they've got a bend across the NAND line, the NAND here, is that we wind up with a short on one of the NAND lines. And I'm going to zoom in here on the schematic and show you exactly what it is that I'm talking about. I'm going to spin the microscope around so that we can look at one edge of the NAND here. Okay, so here we are looking at, and are we on the right board? This is an iPhone 7 Plus. It's close enough. Okay, let's get on the other side of the board here. These caps here, these are really prone to shorting, so I'm going to be checking these first. As you can see, the first one here is 3v0 NAND. We've got a 0v9 NAND line here. These are both 0v9. We should have some 1v8 here somewhere. Yeah, over here we've got PP1v8. So first of all, I'm going to be checking these lines for shorts. So we're actually going to check the first one, the first cap here. We're going to check it on the right side. We're going to check the next cap here on the right side. And then we're going to jump over, we're going to skip these two vertical ones, and then we're going to check this 1v8 one on the right side and see if we can find any shorts there. Everybody's going to think this is rigged if I nail it, but I'm telling you right now, if it winds up being a short on one of these, it's just from pure experience. It's like you see this 2 amp-ish or a 500 milliamp-ish load, and you go right for the common fault points where you always find shorted caps. So that's what we're going to do here. I'm happy to say that I have my on-screen meter fixed, so I'm no longer having to caption in my meter readings. It's actually going to show them to you on the screen. So there we go. We've got a meter reading in ohms. I'm going to switch you back to the microscope here, and we're going to make sure. Gosh, just as I change it to white, I'm going to do this on a white surface that's going to make this. There we go. Let's give you the 0L on the sticker. How about that? I'm going to try to do this really hard without my microscope jiggling. It's not my crazy stand mount that jiggles, it's the whole, it's it's the whole stand itself. It's gotten to be a little bit loose. Okay, so we just said we're gonna chip off the first one here. Okay, so we're gonna check 3V0 there. We're gonna check 0V9 here, and then we're gonna check 1VA here. Is that right? Yes. Okay, so there's our 3 lines that I'm worried that we might have a short on. I'm going to go ahead and I'm going to put my black probe on ground. Now, when doing this, I don't know the exact resistance this is supposed to be. I don't know the exact diode mode measurements that this is supposed to be. What I'm looking for is extreme highs or extreme lows. So I know that if something is reading a really low resistance, that means that we have a short to ground. If something is reading a really, really ridiculous high resistance, then that means a line is open. However, with a lot of things, you cannot depend on resistance mode measurements to decide if a line is open. I've gotten to where I use diode mode pretty well entirely for that sort of thing. So let's have a look at this board here and see if any of these are shorted. First, we're going to check our 3V0 NAND line. Oh, just for everybody watching this who is as OCD as me, let me make the board flat. Okay, 3V0 NAND. Is this on mega ohms? I keep changing the range on this thing on accident, and it has been ruining my life. I actually did a partial rebuild on a backlight circuit the other day, again, like a second time around, because I accidentally changed my meter away from auto range and had it set on mega ohms. Is this thing still not right? Am I set on data hold or something? Let's put them together. No, it's reading. Okay, so we got 1 ohm there. So the 3V0 NAND line, I'm getting open line. The 0V... Oh, seriously? Is it just like... I should be getting a reading. Let's do this in diode mode. Okay, I'm going to put my red probe on ground, and I'm going to put my black probe on the line. We're getting a 0.34. That is an acceptable reading. We're going to check our 095. We're getting a 0.20. It's low, but that is an acceptable reading because this is a low voltage line. It's under 1 volt. Now we're going to check over here on PP1V8. We're getting a 0.29. That is a normal reading. So I didn't magically poof and find the short here. But you know what? PP1V8, that might actually be powered before button press. Don't quote me on that. You know what? Let's learn that right now. Let's hook up the iPhone 7 here. Okay. Let's spin over here and check PP1V8 for voltage. I'm going to put the meter on volts. I'm having a brain fart here. I can't say blonde moment because there's too many people watching. And I'll get criticized. Yeah, see, PP1V8 is not present when the power is off, so I'm not out in left field here. So what we're going to do here, we're going to need to figure out where the short is. Now, in this case, I think a thermal camera would probably be your best bet, although I know people that have them and still don't use them, so maybe that's not true at all. We know it's not any of those lines, so I'm going to do my typical routine here to find a short. I'm going to go... we're going to hook it up to this other cable here that gives me the ability to prompt it to boot without having to use tweezers or anything to short the board out. I'm going to go ahead and I'm going to plug this thing into a DC power supply here. I am worried about the flex that's in this. I'm worried that we've got a really ugly short somewhere. I know it's not VDD boost or VCC main. Okay, now that I got this thing hooked to the power supply, we're going to go Ohm's law. I'm just kidding. We actually have to do real work here. So I'm going to go ahead and prompt this thing to boot. You've got the DC power supply on the screen. Now, I'm going to backtrack just a little bit. I've had a couple of people come forward and asked me to do more of beginner stuff, and honestly, this really is beginner stuff. I should probably do a video on resistance and current and volts, basically Ohm's law, to get to the point of where it is, why it is that I feel like I can find this short by laying my hands on it. See, 2.6 amps, that's going to generate quite a bit of heat. There's with the size of these components, there is some teeny tiny little component that is sinking 2.6 or however many amps, and that is going to generate heat. It should generate quite a lot of heat unless it's a really firm short, but even then we should still be able to track it down with heat, just maybe not so easy. So what I'm going to do here, I'm going to go ahead and prompt this thing to boot. Okay, and I'm going to lay my hand, I'm going to go for the bottom side of the board since we have all the thinness. I'm going to get a couple of fingers down here, a couple of fingers in here like that, and I'm going to prompt it to boot. Really weird thing, it jumped to 3 amps and turned off. It's behaving differently. It jumps to 3 amps and then powers off instantly. Okay. I wonder if this has something to do with me hooking it up with this other supply. So I'm going to go ahead and take this supply off of it. I'm going to hook this supply up to it. Okay. The one that I had on it before. And then we're going to have a look at the board view here, and we're going to find the connector that's responsible for the power button, and we're going to find one that's labeled hold key. This one's actually called power key. Yippee! So here we are, power key, and it's the first one. That's a weird looking strobe driver. Let's look at this under the microscope. Okay, so what we're going to do here, I'm going to use a pair of tweezers to prompt this thing to boot and see if I can get it to stay on just a little bit longer. Okay, so that is going to be not the big fat one here, but the one right up above it. Try to keep that microscope from shaking. It's hard at these magnifications. So what we're going to do, we're going to get this first pin here and short that to ground. Okay, now as you can see, the power supply is drawing 2.3 amps off. Okay, so now we're going to get a loop. Now I'm going to lay my fingers on the board here. Okay, I'm going to turn the supply off. Okay, that's a little long to be. What I'm worried about whenever I'm getting all excited, I'm like, all right, I'm going to turn it off. I'm worried about the boost IC, and I'm worried about the little transistor or whatever it is that provides all the current through VCC main. But by doing this, I've narrowed down now that I've got heat forming up here in the top of the board. Okay, now I realize that phones that produce heat, there's some of the easy solving phones. It's the ones that don't produce any heat and do vague, really screwed up stuff that's extremely hard to follow. They don't leave you much to follow at all. So I do hope that you wind up with easy to follow repairs because it takes the guesswork out of it. When you wind up with a solid trail to follow, many times it's going to wind up in your favor. Okay, so let's go ahead and remove this sticker. Now I'm going to look to see if I can see anything visibly. The heat I was feeling is sort of up here close to the NFC IC. You know, I feel like the heat that I was feeling was right here or above, like somewhere up in here. That's really difficult to say. It's really difficult to say. I wish the dang thing would stay on when I prompted to boot with USB. Let's try that once more. Okay, I'm going to go ahead and hook up the supply that's got my 5-volt USB. And I always say that because if you got a phone hooked to a power supply, or if you got a battery hooked up, and then you just bump the 5-volt USB rail with some power, it'll prompt to boot. Okay, so we're going to hook this thing back up, and even if it doesn't do the same boot loopy thing that we were just now getting, maybe it will at the very least allow me to find this short. So I'm going to, first of all, let's see if it's going to produce any heat for me here. Okay, it's not going to boot loop, it's just going to stay off. That's kind of weird. What if I hold the button down? You know what? I think I was hoping to do this video without using freeze spray. I was going to use, like, if I'm in a hurry and I need to find a short really quick, I just use a drop of alcohol. I don't do it. I don't exactly do it the same way I do it when I'm not recording a video. Sometimes I do it that way just to show for sure. This thing is not producing much heat at all. Let's go ahead. I'm going to hook the other supply back up to it. I'm going to see if we can find this one with alcohol. Okay, so we're going to hook up our 7+ lead here. So we've got the other set of squid cables here, which, by the way, a lot of you have asked where I buy these things. I think the red one here came from Union Repair, and I believe the other one might have came from iPad Rehab. I got one from there and from Union Repair. I'm not really sure, but at some point in time I've wound up hardwiring this to the supply, and I still use the barrel. Let's not get sidetracked, okay? All right, so we're going to turn our power supply on. I'm going to switch you guys back under the microscope, and we're going to flip over here. Let me get a Q-tip in my hand here and ready. We're going to power this board up by shorting this power key thing to ground. We're going to flip the board over because now we're drawing massive amounts of current. And I'm going to begin hunting for this. Well, that NFC IC is drying off awfully fast, isn't it? Right? Oh yeah, look at that thing. We have an NFC short. Ah, look at that. I'm sure that's where it's at. Let me confirm that with my finger. Oh yeah, man, that chip's getting hot. Hot, hot, hot. Okay. Turn this off before we burn something else up. Okay, let's have a look at the schematic and see exactly what that is, and see if there's anything else it could be other than a faulty chip. Okay. Dun, dun, dun. Power key, we don't need you anymore. Okay, NFC RF. Stockholm Ohm's Law. NFC controller, you're getting hot. We got VDD NEC 5 volts coming into it. We got VDC NE da 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 da. We got 1V8 SRAM. We got all this power going into this thing. We have lots of paths to ground down here. Does this thing not capture my mouse arrow? I'm pretty sure it don't capture my mouse arrow. Isn't that lovely? But do we have any power going out? I'm not sure if this thing provides any power going out of it or not. VDD NFC 5 volts. We have a test point for that right here on the top of the board. So if we switch right over to the top of the board here, this test point right here, That's for that NFC 5-volt line. Okay, I'm going to go ahead and set my meter to diode mode. I'm going to put my red probe on ground, and I'm going to use my black probe to check and see what the diode mode reading on that line is. And I'm getting a 0.58, so that's a pretty high reading. I don't suspect that that's causing us any problems. So let's go ahead and have a look here at what other lines we have. We've got 1V8 SDRAM. I know it should not be that one because that's the line we're using for buttons. I believe it's going to be something here pertaining directly to this IC. Could be the IC itself. We could just pull it off there and see. Could also be something directly on the other side of the board getting hot and trolling me. That is also entirely possible. AVDDH. Let's find R. That's going to be too far back under the shield, isn't it? Can I get to this? Okay. Let's get out here and we'll check this line at C5717RF. Okay, so I'll put my red probe on ground. And I'll put my black probe here, and we're getting a 0.33. Okay, what other lines do I have here? We know that this one's good. We checked the 5-volt NFC line, VDD main NFC. Being that it has NFC on it, it's probably on the other side of an inductor. Let's check it anyways. Chances are this is not shorted though. If it was, we would have larger problems to deal with. So that's going to be this one right here. We're getting a point. Oh, you can't see my readings in this. Okay. Okay, so if we check that one, we're getting a 0.30. We're getting a 0.30 there. On this other one here, because the meter was not working, that one there is a 0.33. Those are both acceptable readings. Now, I could be getting trolled altogether. I mean, it could be an entire different line. Okay, now we're going to check... We're going to check this line here, NFC. Let's see, there's not much else on this line other than capacitors, so let's just go ahead and check it anyways. And we'll just pick one of these caps here. How come none of those are... None of those are selecting, so let's skip it, come back to it. Let's go C7505RF. This thing is totally broken. It's no longer linking. Oh, what a pile of junk. Okay. Oh wait, it is now. Let's do C7505RF. Okay. Now to get to C7505RF, I'm going to need to change probes. I'm attaching a probe that's got a little straight pin soldered to it so that I can get down in there. I'm going to put the voltmeter back into ohms mode, and we're going to get down in here and we're going to check these lines right alongside this IC. $350K on that one. That is a very high resistance. 0.6 on this one. 350K on this one. I'm just going to check them all here. That one's doing some weird stuff. So we're getting 1 ohm on this side, and on this side we're getting 1.5 ohms. So this line here, 0.6, 0.5 ohms. and on this side I'm getting 2.6 ohms. So let's go ahead and have a look back here at the board view and see what that one is. This line is PP1V1. Alright. Where else do we have PP1V1? We've also got PP1V1 out here. Now, 2 ohms is still too low for 1V1, so I think I'm probably going to go ahead. And freeze this board and see exactly where the first point of heat here is. Now, let's check and see if there's anywhere where PP1V1 is going to make it into this NFC IC. Maybe it's on the other side of this resistor here. So let's go ahead and look. What is this component? Okay, this is going into something much larger than the NFC IC. This, if this is a RAM short, I'm going to call this a no fix, but I could swear that the NFC is what is getting hot. Let's double check this with a diode mode reading. I'm going to go ahead, I'm going to put my black probe on ground. Now, I'm going to double check. We're going to grab PP1V1 and I'm going to check it in a different spot here just to make sure I'm not doing anything silly like touching the case or anything. We're going to go down here and check C1506. Okay, so I'm putting my red probe on ground, and I'm going to put my black probe on the hot side here of C1506, and I'm getting a diode mode reading of 0.00. Okay, so this is going to be a PP1V1 short. Now, why is it that the NFC IC seems to have gotten hot? Is it possible that I have made a mistake and it's not the NFC that's gotten hot? What if it is this capacitor itself? What if it is something beyond this resistor here, which looks like, what is this going to be? What if it's something beyond this resistor here? I don't think. All right, so I'm going to go ahead. I am going to go ahead and use I'm going to freeze this board. We're going to freeze it, and then I'm going to prompt it to boot and see what gets hot first. Okay, so for that, we're going to hook the 7+ lead up first. Okay. And let's start cooling this thing down. It'll take a minute here for the whole entire board to cool down. Okay, now we have that froze. I'm going to go ahead. We're going to turn the power supply on. We're drawing 0 amps, and I'm going to hit the boot button. Now with the board cold, it's no longer drawing that sort of current, is it now? I hate it when I fix them with freeze spray. Okay, so now, now with the board cold, let's go ahead and see if we still have our 1v1 short down here at C1506, okay? So I'm going to be putting my black red probe on ground, and I'm going to use my red probe. Stay froze, mofo. red probe on ground, and I'm going to use my black probe down here on C1506. And I'm still getting a 0.00 voltage drop to ground. Strange happenings. Okay. Let's go ahead and blow some of the moisture off this steaming pile. Although since I used free spray, there's going to be moisture absolutely everywhere. I'd rather do it with just a dot of alcohol, but sometimes a dot of alcohol is never gonna, just never gonna get it, never gonna get it, never gonna get it. All right. I'm gonna go ahead, I'm gonna gradually warm this board up, and I'm gonna try to evaporate as much moisture as I can. And hopefully I don't have to go back and refreeze it and warm it up and refreeze it. As long as you're making gradual movements with your temperature, it's really not, you know, it's not going to be the end of the world here. I am really concerned that the load is gone when it's frozen, but the short on 1v1 is still shorted. That doesn't make any sense to me whatsoever. Well, that board does have a little bit of a bow to it. Watch this be some goofy CPU problem, and then I wind up shit canning this repair anyways. Alright, so now we're going to hook our 7 Plus supply back up here. It had a little 30 milliamp blip there. It's kind of odd. Okay. Now we're going to power this board up using the tweezers. Oh, and you can see I partially tripped the moisture indicator. Oh no! And we're back to drawing 2.3 amps. Only now it seems like it's getting hot everywhere. Now I'm not convinced it's that NFC chip. Now I'm starting to feel like it's bent more than it should be, and I'm starting to feel all weird about this one. This is going to wind up being a no fix, guys. I bet you anything this is a shorted CPU. Let's see where 1v1 goes to. Okay. Switch you back over here to screen capture. Okay, and let's just zoom in here, and we're going to pick PP1v1. And let's zoom out here. Uh-oh, this is SOC. This is system on a chip. You know what that means? That means it's the CPU. Okay? We're still going to try to verify this because I hate to call no fix on things that aren't actually no fix. Okay, we're going to remove the CPU shield here. I'm going to go ahead and clamp this thing down into a holder. Okay. It's probably not the best way to do that, right? And then I'm going to take a blade and I'm going to cut right across here. So much for sending them back a non-scuffed up phone. All this trouble to keep it clean, and now I'm just going to go cutting it open. Let's start warming this steaming pile up. This is going to be a CPU short, fellas. Okay, so remove this piece of adhesive going across here with my fingers so I can be sure and get burnt as badly as possible. There we are. Yeesh. Let this thing sit all this time waiting for TriStar ICs. And it's going to wind up being a no-fix. That really sucks to have somebody waiting for so long and then have to call no-fix. Look at the crack through this underfill right here. Is this a crack? Oh yeah, baby, that's a crack. Look at that. Here, let me zoom out so you can tell where I started. Okay, here's our top of our CPU. And look at that crack running right across there. Ooh, you can even see it down in here. That's a big crack. Crack kills, guys. When it's around the CPU, crack kills these phones. Can you see the crack? Let me try to brighten that up some. Now the crack's not in the CPU itself, but it's close enough to the CPU. I'm betting this 1v1 short, it's going to be within the CPU. So we're going to go ahead and verify it. Even though I said I didn't want to heat the board up and cool it down, heat it up and cool it down, heat it up and cool it down, let's just try to do it with alcohol. And then if that's not going to work, then I'll freeze it just for the sake of being able to show you. The phone will be toast anyways, regardless. This one is going to be a no fix. This is one of the phones that has been ruining my life for the last few months. You guys may have noticed that my level of enthusiasm has went down by an order of magnitude, and that actually started well before our Florida move, and it has a lot to do with the shift in phones from the 6 Plus to the 7. Many of these iPhone 7s are leaving here without a good verdict, and there's a ton of issues on the iPhone 7 that you just cannot solve, and some of them there's also a ton of issues that you may be able to solve, but your odds of having complete total success where the phone's going to be perfect after you're done with it gets to be lower. And it winds up being a losing deal. The iPhone 7 has been somewhat miserable, and I know I'm not alone in saying that. So let's go ahead and add some alcohol to the sock here, and I'm going to hit the button to boot. Whoop! There it is. Bam! Instantly. Did you see that? And I did it without having to chill the board off again. So let's go ahead and add some alcohol to this again. Okay. Now I'm going to push the button in 3, 2, 1. Bam! Bam. Okay, see, that's, we have a short within the CPU on this one. That's undeniable. If you flip the board over and look at the other side, that short would be like somewhere over here. It's not, the heat could not possibly and instantaneously travel through the CPU that fast. So we'll do this one more time. Add some alcohol to it. 1, 2, 3. And just instantly, it's bam, hot on the CPU. And if I held it down, it's going to make a square, It's like, it's weird how they do that. So, guys, I cannot count how many iPhone 7s now with shorted CPUs that I've ran into. But I'm going to tell you, it's starting to haunt me bad enough to where whenever I run into this 2.6 or 2.5 whatever amp draw, it's going to get to be more and more often where I turn to the CPU first rather than checking the components that are commonly shorted. It's just, the iPhone 7 and the 7 Plus is a big old fat hairy lemon. These things, they go in for screen replacements and they come out not getting service. And if you're in the screen repair business, or heck, even me in the micro soldering business, I have one here that came in for not charging, okay? Basic not charging repair, right? Get it done. No service, and that is an issue with the baseband CPU itself, and it's just these things can be a royal pain in the neck. They're brittle, they fall apart. The chips, for whatever reason, they short internally. Like, this is a CPU short. Now, Okay, I'm starting to be too hard on Apple. I can confirm that this phone does have a bend right across this spot. Okay, so that is the cause for this short. It's just, they have a lot of problems, man. These things have a lot of shorts, a lot of problems. You rarely ever get to dig into one and just fix a problem. It almost always winds up being a subset of problems. And, you know, that was the case on the 6 Plus, but on the 6 Plus, at least the subset of problems were almost all caused by technicians trying to fix touch disease. Like, you would know whenever you got a 6 Plus in for touch disease, there was a high probability of it having long screw damage, and if you got a 6 Plus in for long screw damage, there was a high probability that they long screw damaged it while trying to fix touch disease. You know, it was a predictable situation, whereas on the iPhone 7 Plus, all bets are off, man. You got all that technician damage stuff going on, as well as a huge variety of failures that happen from this right here. Whoop! I just shorted baseband. Oh shit, I dropped it this high. Anyways, guys, I think I'm going to go ahead and post this video. I don't know if I've ever posted any failures, but I'm here to tell you, whenever it comes to the iPhone 7 and 7 Plus, I have had more no-fixes than any previous model before. Now, I do have a large success on them. I mean, I do have a lot of success. That's why I'm still paying my bills, but as far as the success rate, it is so much lower with the 7 and 7 Plus, and it's just, that can be a tough one to swallow, because being successful makes you feel good, and whenever you start to have more failures and less success, it makes you feel really, really bad, especially whenever customers are not all that understanding. Anyways, I think I've talked too long for a no-fix. I'm going to go ahead and call an end to this video, and I will see you guys soon. Have a good day. Thanks for watching.